instructions. So first one is a data transfer instruction, arithmetic instruction, logic instruction, control transfer instruction, machine control instruction. So coming into a data transfer instruction, the data transfer instruction that transfers a data from one location designated as the source location to the another location designated as the destination location. So one register, it can transfer the data from one register to another, one memory location to another memory location to a register, register to a memory location. Data transfer instruction. Data transfer operation of the 8085 microprocessor are of three types, namely move, load and store. Move, destination, source copy data from the source to destination location. LDA, address copy the data byte at the memory location specified by the 16-bit address into the accumulator. STA, address copy the data from the accumulator to the memory location specified by the 16-bit address. Arithmetic instruction. Arithmetic instructions performed by microprocessor include addition, subtraction, multiplication, division, comparison, negation, increment and decrement. These operations are supported by the 16-bit and 32-bit microprocessor. Arithmetic instruction. Add R adds the contents of the register to the accumulator. ADI, 8-bit, adds the 8-bit data to the accumulator. Sub R subtracts the content of the register from the accumulator. SUI, 8-bit subtracts 8-bit data from the content of the accumulator. Increment R increments the content of the register. Decrement R decrements the content of the register. Logic instruction. The basic logic instruction performed by all microprocessor are AND, OR, NOT and exclusive OR. Other operation includes shift and rotate. Logic instruction. The basic shift operations are the left shift and the right shift operation. In the shift left operation, all the bits are shifted one position to the left with the rightmost bit set to the 0 and the leftmost bit transferred to the carry position in the status register. In the right shift operation, also known as logic shift right, all the bits are shifted one position to the right with the leftmost bit set to 0. These are the two shift operations. Coming into a logic instruction. The example of logic instructions performed by 8085 microprocessor include the following. ANA R bar M. Logically AND the contents of the register or memory with the contents of the accumulator. ANI 8-bit. Logically AND the 8-bit data with the contents of the accumulator. ORA R bar M. Logically OR the contents of the register memory with the contents of the accumulator. ORI 8-bit. Logically OR the 8-bit data with the contents of the accumulator. XRA R bar M. Logically XOR the contents of the register memory with the contents of accumulator. XRI 8-bit. Logically exclusive OR the 8-bit data with the contents of the accumulator. CMA complement the contents of the accumulator. RLC rotate each bit in the accumulator to the left position. RRC rotate each bit in the accumulator to the right position. Control transfer or branch or program control instructions. The microprocessor executes the instruction in a sequential manner. Branch instruction change the flow of the program either unconditionally or under certain conditions. Branch instruction include jump, call, return and interrupt. Coming into a jump instruction. Jump instructions are of two types, namely unconditional jump instruction, conditional jump instruction. If the microprocessor is so instructed as to load a new address in the memory counter and start executing instruction at that address, it is termed an unconditional jump. In the case of a conditional jump, the program counter is loaded with the new instruction address only. If and when the certain instructions are established by the microprocessor after reading the appropriate status of register bit. Call, return and interrupt. Call, return and interrupt. Call instruction transfers the flow of program to a subroutine. The call instructions differ from jump instruction as call saves a return address on the stack. The return instruction returns control to the instruction whose address was stored in the stack when the call instruction was encountered. Instruction interrupt is a hardware generated call or a software generated call. Examples of transfer control instruction of 8085 microprocessor. JMP 16-bit address. Change the program sequence to the location specified by the 16-bit address. JZ 16-bit address. Change the program sequence to the location specified by the 16-bit address if a 0 flag is set. JC 16-bit address. Change the program sequence to the location specified by the 16-bit address if a carry flag is set. Call 16-bit address. Change the program sequence to the location of the subroutine specified by the 16-bit address. RET. Return to the calling program. Machine control instruction. Machine control instruction include halt and NOP instruction. Halt, stop processing, wait. NOP, no operation. These are the two operations it does. Addressing mode. Microprocessor perform operations on data stored in the register or memory. The data can be specified in various ways as a direct data value or stored in some register or memory location. These are referred to as addressing mode of the microprocessor. The types of addressing mode. Most commonly used addressing modes are absolute addressing mode, immediate addressing mode, register direct addressing mode, register indirect addressing mode, indexed addressing mode, implicate and relative addressing mode. Absolute or direct addressing mode. In absolute addressing mode, the data are accessed by the specifying their address in the memory. The mode is useful for accessing fixed memory locations. For example, the instruction move A, 30H in the 8085 microprocessor moves the content of the memory location 30H into a accumulator. In this case, accumulator has the value 07H. This is an example of the operation. Immediate addressing mode. In the immediate addressing mode, the value of the operand is held within the instruction itself. This mode is useful for accessing constant value in a program. It is faster than the absolute addressing mode and requires less memory space. For example, instruction MVIA hash 30 moves the data value 30H into the accumulator. Register direct addressing mode. In the register direct addressing mode, data are accessed by specifying the register name in which they are stored. The operation on registers are very fast and hence instruction in this mode requires less time than absolute addressing mode instructions. For example, instruction move A, R1 moves the content of the register R1 into the accumulator. The content of the accumulator after instruction R06H. You can see here. Register indirect addressing mode. In the indirect addressing mode, uses a register to hold the actual address where the data are stored. In the register addressing mode, the address is specified indirectly and has to be looked up. This addressing mode is useful when implementing the pointer data type of high level language. As an example, instruction move A, at R0 moves the content of the memory location whose address is stored in R0 into the accumulator. The value of the accumulator in this example is 07H. Indexed addressing mode. In the indexed addressing mode, the address is obtained by adding the contents of a register to a constant. The instruction move the contents of accumulator A to the memory whose address is given by the contents of register. Addressing mode is used to access a continuous table or array of data items stored in the memory. Relative addressing mode. It is also called as implicit addressing mode. No operand is used in the instruction and the location of the operand is obvious from the instruction itself. Example, carry flag returned from subroutine. The relative addressing mode is used for jump and branch instructions only. By this, we complete the microprocessor topic. Thank you.